Problem 2 is done.
Problem 3, out of time.
Let's hope that you're not out of time.
Students have busy lives. They cannot spend too long waiting for the professor to see them. Since a student does not know how long the lineup will take, they arrive and wait for the professor. But they can only wait until a certain time before they are forced to go to their next class without seeing the professor. Extend your solution to problem 2 to include the following behavior.
So we'll have to think about what we need to change to make this happen. Okay, so if we look at this, the input changes again. This time we get another integer, so we still have TSR, that's the same, and now we have a D denoting the time until the student is willing to wait to see the professor. And if we look at the processing, we have that everything about the student arriving, the student leaving, and the next student all is the same as problem 2, but problem 3 now has that the student runs out of time. And the output is the same, except we have this new line which tells us that the student leaves due to lack of time if they cannot wait any longer. And so we'll look at the examples later, but first we'll copy everything from problem 2 into problem 3, and I'm going to snag this tiny detail because this is what we need to do. So this is sort of our step. We had step 2, the student leaves, step 3, the next student, and 4, I'm going to make that 5, because in this example we have another step in the mix, and this is our new step 4, which is the student runs out of time. And what we're told is if the current time is the same as the waiting student's departure time, then the student leaves the waiting line. If 2 students have the same departure time, they depart in the order they are in the waiting line. Okay, well, the first thing we need to add there is input. And that is, we need this new time until which the student is willing to wait. And so we see, again, we're going to go back and update the student. And in this case, we're going to create another integer, and I'm not sure what it was called, but essentially the wait time. We'll call it wait time. And after that wait time, they must leave, or maybe we'll call it departure time. Okay, and in this case, we're still going to have to create another constructor method. So I'm going to copy, because I need those same 3 from problem 2. If you haven't seen problem 2, watch the video before this. And we're going to expect one more integer, which is the departure time. And again, we're going to update this, the departure time, with whatever is passed. And we know that we're reading in that extra piece of information, just as we updated last time. When we read in the input, we're going to read in another piece of information. So int departure time is a new input, and we're going to pass we're going to pass in departure time to that extra constructor method. And so now this time it knows, again, Java is so cool, it knows to call that other constructor method, and so we'll have now, our students will all have an associated departure time. And the only time that we need to make use of that is they still arrive the same way and line up in the hallway, they still leave the same way, they still decide if there's a next student that goes into the meeting the same way, but this time there's also this possibility that they could run out of time. And so what we want to do is loop through every item in the hallway line. So we want to loop through every student S in the hallway lineup. And Oh, have we used this before? Oh, yeah, we've already used S. So I'll call it student. And what we want to do is navigate through each of those students. We're going to see if they're the student dot, oh, we didn't create a getter. So in the students, we created this new departure time, but we need to create a way to see that because I made that a private field. So I'm going to return get departure time. Departure time. Okay, so then if we go over here, now we can say get departure time, and if that is equal to the current time, then what we want to do is have them leave. But first, we want to output print line the time plus the student name, get name, and then I forget the exact framing, but it's something about them leaving. Let's see what it says. Our output is going to be something of the form leaves due to lack of time. We never want that to happen, of course, during office hours, but we know that sometimes it does because students are busy and sometimes the lines get long. Okay, so we want them to do that, but then we also want to have them leave. And so the way that they leave is actually kind of interesting. So we can't actually remove them if we go through it like this. So because we would be then updating that which we're looping through. So we can handle this in one of a few ways, but I'm going to handle it because I want to update the hallway lineup while I'm in here. Essentially, I want to remove them from that. So what I'm going to do is I'm going to create another linked list just to store them for now, a student. And it's going to be everyone departures. So it's going to be the list of all the students that are departing at the moment because of lack of time. And so what I want to do then is I'm just going to add the student to that list of departures, and then when I'm done, and because I'm going through it in order, then I can go through the list of departures, student in departures, and I can remove them. So yeah, I'm going through the list of departures, but now what I want to do is go through the hallway lineup, and I want to remove the student from that list of departures. Okay, and then I'm done. So let's run it. And I'm just going to grab, oops, first I'll grab the input. We grab the input. And we run it. We'll see at first glance, it seems like things are maybe okay. I see it ends the same at any rate. So Alice arrives at time 60. She sees a professor, no one's in line. She only takes 5 minutes. Bob arrives, Alice leaves, and Bob sees the professor. At 66, Carol arrives, and she's not able to see the professor, so she leaves the queue. Bob starts at 65. It's going to take him 15 minutes, so he'll get done at time 80, which he does. Carol arrives at time 66, and she needs 10 minutes. She should leave 10 minutes after she sees a professor, but she can't see the prof until after Bob leaves, but that's too late for her because her last time before she has to go off to class is time 79. So at that point, she leaves due to lack of time. Bob finally leaves at time 80, and Dave sees the professor and then leaves. So Carol's our only lack of time. So that's it. We're done. Good luck next time. See you then. Happy coding.